Greetings on a very cold morning. So I'm going to start a section in the encyclopedia on modules that I call CV modifiers. And what I mean by this is that they are modules that in and of themselves don't really produce any CV. What they do is that they take incoming CV and they modify it in certain ways. And so today I'm going to talk about the CV invert and the CV rectify, which I think are two modules that people aren't quite sure what the difference is between them. And so we'll go over what that difference is and talk about a couple of different ways to use them. And you know, the final note that I'll leave on is if you'd like to support the work that I do with ZOIA, my Patreon information is there. It's appreciated, but there's no obligation. And I guess because this comes up often enough, I'm not an employee of Empress Effects. So I'm not receiving any compensation from them to produce material like this. It's just something that I do because I like ZOIA, I like the community, I want people to be as happy as I am with ZOIA and have as much fun patching with it as I do. So I think the easiest way to explain the difference between the CV invert and the CV rectify is with a little bit of math, not a lot of math. They both essentially follow mathematical processes, so you know, it can't be avoided entirely, but the math is really not that complicated. So the way to distinguish them is to see what they do to CV that changes over time. So what I've done is I've mapped my MIDI CC mod wheel to a value module. And I'm going to place a CV invert, and notice that they don't have any options when you place them. These are very basic modules. All they really do is modify or transform incoming CV. I've got a value module that goes from 1 to -1, which is one of the options when you place the module, or you can go to the option menu. And again, I've got it hooked up to my MIDI CC, so I can just go whoop, whoop, so that I can sweep between 1 and -1. And I'm going to connect that to both of these modules' inputs. The first thing I'm going to do is just describe what's going to happen. For the CV invert, what it does is pretty simple. It takes any CV that it receives and it multiplies that by -1. So if we have this value module going from 1 to -1, the CV invert is going to do the exact opposite. You know, I won an award in elementary school for art that was based on geometry. So obviously I'm showing off my skills at drawing a not even close to straight line. Anyhow, so what the CV invert does is it takes any CV that comes in and it multiplies it by -1. So since we're sweeping from 1 to -1, the CV invert, if we look at its output, is going to sweep from -1 to 1 and back again. The CV rectify does something very similar, but it says it has a condition. It says if CV is negative multiplied by -1. So it uses an if-then proposition. And if we really wanted to, we could build our own CV rectify using a comparator and an inverter, and it would be very cumbersome, but this process just does it for us. And what we're going to see when we look again is that it will follow the value module until it reaches this 0 point, and then it'll start bouncing backwards. So as the value goes negative, the CV invert will multiply that by -1, and the negatives cancel one another out, and it will start to go positive again. So a CV invert essentially keeps a value from ever going negative. Let's look at its output. So again, we're at 1 on the value module. We start going down, and then we hit this point where the value module is still going into the negative. It's still passing through this part, but we're starting to bounce back with the CV invert. And that's really all these modules do. The applications for those can be pretty wide-ranging. And so, you know, while they're simple, a lot of the most simple modules have the most profound effect. And I'm going to spend a lot of time talking about the CV invert in particular, because it has the ability to really help with something called range finding. So there are a lot of uses for the CV invert module, and I'm not going to be able to cover all of them. The two that I want to spend a little bit of time on, though, are really important ones. The first is simply for creating negative values for things that don't possess negative values. And a good example of this would be something like an envelope follower. So if you wanted to use an envelope follower to affect, say, the rate of a tremolo, an envelope follower just listens to the incoming audio and produces a CV value based upon its amplitude, its volume. So the louder something is, the higher the CV value, the quieter, the lower the CV value. But it only does positive values because we don't have something called negative volume. You know, there's only no volume and some volume. So an envelope follower, for instance, if you wanted to use an envelope follower to affect the rate of a tremolo, if you apply it, you know, the tremolo rate will go, you know, this is our base rate, and as you apply it, it'll go faster, right? But if you wanted to have the opposite effect, where it went from faster to slower, then you would use an envelope follower that went into a CV invert. This is a really basic application for the CV invert, but it's a really important one. If you wanted to use an ADSR, ADSRs don't create negative values. If you wanted to use a sequencer in the negative realm, all of these are modules that can't in and of themselves output negative CV. So you would apply a CV invert to them. So I want to talk about what I think is the most essential use of a CV invert. And there are a lot of good uses for CV inverts. I don't want to say that this is the only use for the CV invert, but this is the one that I think can most dramatically affect how you use ZOIA. It's the one that I think I use the most often. And the more and more you use it, the more invaluable it seems. And that is for range finding. And what do I mean by range finding? the idea of range finding is essentially a way for ZOIA to know where a parameter is set to and to sweep within a specific range. And the way that it does that is with the CV invert, invariably. So I'm going to use two examples. Let's say I have my synth voice set up and the filter's set there, and I want to sweep from its current parameter to 0. I want to close the filter. I want to go down in frequency each time an LFO cycles. The way I can do that is by attaching what I'm using to set the filter frequency is my trusty mod wheel, which is coming in through a MIDI CC in module. It goes to the filter frequency, right? So I'm adjusting my mod wheel, and I want to be able to set the sweep of an LFO so that it closes the filter each time. Now I can, look at my current value and eyeball it and adjust the connection strength from the LFO to the filter. I could do that. I could invert the LFO to do that so that it sweeps downward, right? We discussed how, if you want to create a downward sweep, you can use a CV invert. And this is a really useful application of the CV invert in a lot of ways. But the problem is, what if I decide I want to change the range of that sweep? Then I have to go through and adjust everything and figure out all the math. And what this does is puts a little bit of math up front. And it's just conceptual math as I explain it. So you have to do less math in the moment, and you can create much more dynamic controls. So if we take our value of 0.47, I'm going to round off a little bit here, and we multiply by -1 as our CV invert does, we get -0.47. When we add those together, we get 0. So our CV, the output of our CV invert can always be added to our CV source to produce a value of 0. And this becomes really useful because what we can do with that is set up something that modulates between that value and 0 as it sweeps across that range. So if we send our value through a CV invert, it's going to come out the other side like so. And we can connect that to a multiplier and our LFO to the multiplier. And the multiplier here is producing a depth control. What it does is it limits the range of the LFO. We're multiplying by some amount to produce a range that is less than 0 to 1. As the LFO, if you don't adjust its connection strength, if you don't adjust its depth, it'll just sweep from 0 to 1, open, closed, and the problem with that is that, it can overshoot the range. If we want to sweep from 0.47 to 0, and we just invert an LFO and apply it, it's going to spend part of that time on the number range. We have 0 here and 1 here. It's going to spend part of its time below 0 and not provide any modulation at all. So the advantage here is that we can create an exact sweep. We can go from our current position down to 0. As the LFO rises in value, it rises toward 1, and that 1 gets multiplied by our inverted value and produces 0, right? These two get added up at that point. And we can create a sweep that goes from our current position to 0. And the advantage here is that I can change the current position and the LFO will always know, quote unquote, how far away from 0 it is. You don't have to adjust the connection strength. That's being done automatically through this CV invert. And so this is really valuable for finding the range to 0. But let's say, and this is where it gets, I think, really useful, you want to open the filter. You want to be able to adjust the parameter and change how it sweeps to 1. We want to find its range to 1. We need one more module to do that, and it's a pretty simple one. It's an invaluable one. What it is it's a value module that is biased to 1. Okay. And what we're doing here again is if our value is 0.47, we're multiplying it by -1, we get -0.47. Pretty simple stuff. When we connect the output of our CV invert to this value module biased to 1, all CV sums at inputs. So this is essentially being added to 1, and we get the difference, the difference between 0.47 and 1 at that point, which should be 0.53. Here we have a slightly different, it's 0.181, and our output is 0.819. And as I sweep through my mod wheel, these will change, right? So as this number goes higher, the distance to 1 will decrease. So the output here will go lower. I'm sweeping my mod wheel up to its maximum and then back down to its minimum. And with this other range finding, let's listen to our filter. Oops. So anyhow, as I adjust the parameter, it always knows, again, how far it is to 1. It knows its range to 1. So with the CV invert, we can find these two extremely powerful ranges, from 0 to our parameter, and then again from our parameter to 1. And combined with some other things that I'm going to talk about in a little more detail when I spend time with the multiplier, we can create controls that have feedback. And what I mean by feedback is not like guitar, feedback. What I mean is that they're cognizant of the conditions of the patch, right? They can respond to that. We already hear this in these examples. What we're creating is feedback for our LFO to know exactly what range to sweep from. If we want it to go to 0 or if we want it to go to 1, it knows exactly what its quote-unquote connection strength should be. So this is a little bit of a more complicated process, but it ends up saving a ton of time and makes doing a bunch of different types of modulation and connections way easier in the long run. The one other thing that I'm going to talk about and not demonstrate in great detail, because you'll get it for yourself, I'm positive, is the way in which it can create an inverted LFO. The LFO has to be at sweeping from -1 to 1. And if we feed this into our CV invert, I don't know if you can follow. I don't know if you can follow both of these lights at once, but one's lighting up and the other one's going quiet. It's a really fast way to create an LFO that is exactly out of phase. But it has to be a -1 to 1 LFO, because when one of the LFOs is at 1, the other one is at -1, and vice versa. If we inverted a 0 to 1 LFO, then we would have one where when one was at 1, the other one would be at -1, but when they were at 0, they'd both be at 0, so they'd be mirror images of one another, if this is our 0 line, which also has its uses. But sometimes you really want to be able to quickly create an LFO that exactly mirrors the LFO that you're using, to create one that is on when the other is off. This comes up a lot with loopers and recording. If you want to automate record, this is one way to do it. So anyhow, that's all I'm going to say on CV inverts. There's still a lot of other applications for them. This is not exhaustive, but particularly with range finding, I think CV inverts become one of the most invaluable CV modules that we have available to us. All right, thank you. So I'm going to briefly touch on some of the uses for the CV rectify module. But to be fair, honestly, it's a module that's pretty case specific. It comes up every now and then in certain applications where you sort of realize you need the CV rectify. And one way that you'll know that you're in one of those situations is you'll never use it in a situation where your CV values are only positive. Because again, the CV rectifier doesn't do a thing with positive values. So a really simple application of the CV rectifier is in wave shaping. And you can produce some interesting waves using the CV rectifier. The first place I'm going to begin is with this LFO, and I don't want it to be a triangle. I want it to be a sine, because a sine is uneven in its sweep, or not equidistant at all times. So if we look at our sines output, we've got normal sine stuff, and it's sweeping from 1 to -1. If I connect it to our CV rectify, and we look at its output, we see that we get this sort of humped shape. And this is actually a type of LFO that's used a lot in tremolos. It's not quite a sine, it's not quite a triangle, it's somewhere in between those two. It's humped shaped. And so, you might see this come up sometimes as an option in some modulation pedals. It's a half sine is essentially what it is, because each time the sine dips into negative, it gets flipped. So you only get half of its sweep. So we don't get the curve at the bottom. The curve at the bottom gets flipped onto the top. So, if we start playing around with some of those options that we went over when we talked about the LFO, particularly something like swing amount, goodness gracious, I didn't say done. We start messing around with its swing amount, we can get even weirder shapes. And again, that may be useful to you if you're looking for a unique form of modulation. So the other applications for the rectifier often come up in mixing, particularly if you're trying to mix multiple sources using one value. If you look on the tips and tricks page, there's something called an LFO blender that William Zenhorst put up on the ideas forum, and I put it on the tips and tricks forum. It also works for blending 3 audio sources in a continuous sweep. That's the advantage there, as opposed to a mixer where you have to adjust each value one by one. So you can use the rectify to mix values with a -1-to-1 module, because as the -1-to-1 module starts going low, one of the other CV sources or audio sources will go to 0. It'll go to silence, and another one will start to rise. I wanted to look at one that I've actually used, and again, there really aren't a ton of uses for the CV rectify. It's not a hugely important module, but I wanted to go over one more. Again, I'm connecting this -1-to-1 module that I have just hooked up to my mod wheel. And what I've done on this page, this is our synth voice, which I talked about a little bit in the first chapter of the encyclopedia. I'm not going to go over it in great detail here. But what I've done is I've split its signal. On one side it goes through a low pass filter, and on the other side it goes through a band pass filter. And my -1-to-1 module is hooked up here, and I also have a value module that is biased to 0.5 that's hooked up to the channel select. And basically what that means is that when my -1-to-1 module flips from positive to negative, the channel will switch. And then the rectify goes to the frequency of these two filters. So what you're going to hear is the low pass filter, as the -1-to-1 module moves from negative to positive, it will go down in frequency. We can watch that happen actually. Let me adjust the mod wheel. So this is my value module, the -1-to-1, sweeping from -1 to 0. And it looks like a positive sweep because again the CV rectify is flipping that. And then once it sweeps through 0, it's going to flip over the channel, right? You can see that happen. We go to channel 2, and now we're raising this bandpass filter's frequency. So I can sweep across both of them. It sounds something like So that's one application of the CV rectify that I've actually used, where I wanted to create a control where I could sweep across a low-pass filter into a bandpass filter in one sweep of the control. And obviously you could use a single state variable filter for this with a low pass and a band pass output. It would work exactly the same. I just wanted to separate them for the purposes of demonstration.